Hey guys, welcome to another video. This is going to be the last video for the practice drill for Unit 2. This video is going to have also 4 questions similar to the second and first video. So in the first question we got f of x is equal to x e to the power of 2x. We got 2 sub-questions. The first question is basically find f prime of x. So basically, since f of x is of the form of u multiplied by v, because this is a product of 2 functions, so f prime of x is going to be u prime v plus u v prime. Therefore, f prime of x is going to be 1 e to the power of 2x plus x, and then the derivative of v is going to be 2e to the power of 2x, because the derivative of e to the power of u is going to be u prime e to the power of u. So this is going to be my derivative over here, which is e to the power of x, 2x, plus 2x e to the power of 2x. Now in part B, they told me find the x value for the critical point of f of x, which means that I have to set f of x is equal to 0 so I can find my x. And over here, they didn't say the word coordinate, if you notice. They said only the word x value. So it's enough for me to find the x value and not find the y value with it. So basically, we need to set e to the power of 2x plus 2x e to the power of 2x equals 0. So now we can take e to the power of 2x as a common factor, and then you will have 1 plus 2x inside equals to 0. How do we factorize it? We factorized it because we look at these terms and the only thing we have in common over here is basically e to the power of 2x and e to the power of 2x. So if you take e to the power of 2x as a common factor, so when you multiply it by 1, you're going to get this term over here. And then when you're going to multiply it by 2x, you're going to get this term over here. So this is the way to factorize this exponential function. So now we have to understand something over here. In order for us to find the critical point, we need to see what x value would make all of this equals to 0. Now I know for sure that e to the power of 2x is always positive. There's no way for this to be 0. Whatever number you put instead of x for e to the power of 2x, it's always going to end up being a positive number. No way for it to be 0. So the only part that could be 0 is actually over here. So we can say that 1 plus 2x is equal to 0. So 2x is going to be equal to negative 1. Therefore, x is going to be equal to negative half. So if x was equal to negative half, put it over here. Negative half multiplied by 2 is going to be negative 1. Negative 1 plus 1 is going to be 0. So if all of this is going to be 0, 0 multiplied by this piece over here is going to result with a 0. So this is how you verify that this is actually my critical point. Now, this is it for question number 1. Now, question number 2 is fairly simple. They're saying over here, using chain rule, differentiate the following. So in part A, f prime of x is going to be 5, 6x to the power of 2 plus 3, all of it to the power of 4. Don't forget to multiply by the derivative of inside according to chain rule. So it's going to be 12x. Now in part B, f prime of x, it is going to be 3, negative 2x plus 3, all of it to the power of 2. And then you multiply by the derivative of inside, which is going to be negative 2. Now, in part C, f prime of x over here, it's going to be 4 cosine to the power of 3x. And then you multiply it by the derivative of the inside, which is the derivative of cosine x over here, which is going to be negative sine x. And then part D, f prime of x, it is going to be 3 sine squared x. And then you multiply by the derivative of inside, which is going to be cosine x. So this is it for question number 2. There's literally nothing scary about number 2, to be honest. Now, question number 3, we have a table of values. we are having that when x is equal to 4, the f of x is equal to 1, g of x is equal to 3, f prime of x is equal to 5, and g prime of x is equal to 2. So they're basically saying that when x is equal to 4, the values of f, g, f prime, and g prime are in the table over here. So in the first question, they told me to, using the table, find h prime of 4, where h of x is equal to f of x multiplied by g of x. So this is going to be my u multiplied by v. So h prime of x, it is going to be f prime of x multiplied by g of x, which is going to be my u prime v, plus my u v prime. So h prime of 4, it is going to be f prime of 4 multiplied by g of 4 plus f of 4 multiplied by g prime of 4, which is going to be, f prime of 4 is going to be 5 multiplied by g, which is 3, plus f, which is going to be 1 multiplied by g prime, which is 2. So 5 times 3 is going to be 15, plus 2, 17. So the answer for the first question is 17. Now in part B, we're going to do something very similar over here, but over here we have f of x over g of x, and we want to find t prime of 4, where t of x is f of x over g of x. This is a quotient function, u over v. So t prime of x is going to be u prime v minus u v prime over v squared. Or in the terms that they gave me over here, f prime of x, g of x minus f of x multiplied by g prime of x over g of x squared. So basically, now I want to point out something over here. I've seen many people make this mistake, and they usually write equal and then they put the numbers quickly, but that's not the proper way to represent it. First of all, you state the derivative as I did over here, and then instead of saying equal, you can literally just say, so t prime of 4, and then you put the numbers, okay? Because there's a huge difference between t prime of x and t prime of 4. So t prime of 4, it is going to be f prime of 4, which is going to be 5, multiplied by g of 4, which is going to be 3, minus f of the 4, which is going to be 1, multiplied by g prime of 4, which is 2, over g of 4 to the power of 2, which is going to be 3 to the power of 2. So 5 times 3 is going to be 15, minus 2, 13, it is going to be 13 over 9. 5 times 3, 15, 4, 13 over 9, yes. So part C, z of x is equal to e to the power of g of x, and they want me to find z prime of 4. Now, z prime of x, according to chain rule, it is going to be g prime of x, e to the power of g of x. So z prime of 4, it is going to be g prime of 4, e to the power of g of 4. So g prime of 4, it is going to be 2, e, and g of 4, it is going to be 3. So the answer is 2e to the power of 3. You can keep your answer like this, or if you plug it in on a calculator and then you just write it as a decimal number, also fine. Part D, r of x is equal to sine f of x, and they want me to find r prime of 4. So r prime of x is going to be f prime of x cosine f of x, according to chain rule, which is like u prime cosine u. So basically, so f prime of 4, sorry, r prime of 4, it is going to be f prime of 4, which is going to be 5 cosine, and f of 4, which is basically 1. So you can leave it as 5 cosine 1, or you can put it on a calculator, get the final answer as a decimal form. All right, So this is it for question number 3. Now the final question is a graph question. Now, apologies, the graph is not as aesthetic as it should be, to be honest. It's not very great, but it is what it is. So we have given the graph and we have the equation of the graph, which is minus x squared plus 9. The first question is basically using the graph, find the coordinates of the turning point, which is basically the critical point. So if you look at the graph, the critical point is basically the point where the graph starts to change directions. That being said, if you look at the point over here, this is basically the point where the graph is turning. So that is my critical point over here. And the coordinates of this point, the x value of this point is basically 0. And the y value is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be 0, 9. So according to the graph, the point is the critical point. I'm going to call it crit point is 0, 9. Now in part B, they said calculate the coordinates of the critical point by differentiating y. So they want me to find this point over here using a different method, using the method of differentiation. Now y is equal to x squared minus plus 9 minus x squared plus 9. So to find the critical point, oh sorry, I made a mistake over here. Y is equal to negative x squared plus 9. So basically, we want to find the critical point. Therefore, I need to find y prime is equal to 0. So I need to set y prime is equal to 0. So y prime first is going to be negative 2x. So if you set it equal to 0, then negative 2x is going to be equal to 0. So x is equal to 0. Now, if you plug in x is equal to 0 in the original function to find the y value, so replace instead of this x over here, you're going to get y is equal to 9. So the point, once again, is verified to be 0, 9. The final question over here says, when y prime of 0, when y prime is less than 0, strictly, does that necessarily mean y is less than 0? Explain your reasoning. Now, we want to understand that y prime is basically the direction the function is going. So as long as the function is going up, y prime is positive or greater than 0. And as long as the function is going down, that means y prime is negative. But it is enough for me to choose a point from the graph that disproves this statement over here. So they're telling me that whenever y prime is negative, so y prime is less than 0. So they're talking about this piece over here when the function is going down. They're saying that as long as the function is going down, y is always negative. But we can see literally a point over here on the graph. If you take x is equal to 2, the function is over here, which is 5. So 5 is literally bigger than 0. It's not negative. So that is a counterexample for the statement that they said. You found a point where the function is actually going down. The derivative of it is negative. However, the function itself, the point, is positive. So according to the graph, at x is equal to 2, positive 2, we have y equals 5, which is positive. But y prime of 2, which is negative 2 multiplied by 2, it is basically negative 4, which is negative. So it's not necessary to have y less than 0. So once again, you found a point on the graph which disproves the statement. Whenever the function is going down, that doesn't mean the function itself is negative, because over here that point is positive even though it is going down. So yeah, basically this is the end of this practice drill. I hope you benefited a lot from these 3 videos, as they are very essential. Thank you guys so much.